In this video, we're going to take a look at reaction types. So far we've been balancing equations, but now we want to group these equations into five separate types. That way we can take a look at them and get an idea of like what kinds of properties each one has. And to do that, I'm going to use some social interactions that you're all kind of aware of. Before we get too far, we need to make sure that we have our vocabulary down. So an element is any pure substance that is made from one kind of atom. So we could represent that by a circle, right? That's an atom. An element, if there's more than one atom, they all have to be identical. And in this presentation, we're going to use people. So here I have a person, and if I wanted to have more than one and still be an element, they would have to be twins. A compound is different. A compound is made when two or more different elements bond together, right? So in this video, we're going to show them holding hands to say that they have a bond, that they are stuck together. So if we were talking chemistry, I would show you circles that were different and they were stuck together. They're bonded, they're chemically bonded. And in this presentation, I'm going to have couples and they are going to be holding hands to show that they are bonded. Okay, so the first type of reaction looks like this. We start off with two single people. We're going to add two single people together to make a couple. So I'll help you out on the first one. If I asked you to describe the people's interaction shown above, I would say that they were dating or they're married. Somehow these two single people came together and now they are bonded somehow, right? Chemists don't talk in terms of dating and bonding. Chemists are going to talk about synthesis reactions. So synthesis meaning to push together, to put everything together into one. Okay. Chemically, it would look like this. So you take a magnesium and a sulfur and you add them together and you get magnesium sulfide. Or you take a sodium and a chloride and you get sodium chloride. Or you take nitrogen and hydrogen and make ammonia, right? So you're taking these individual elements, you're sticking them together to make a new chemical. You're synthesizing a chemical. Now, when you look at these, you're going to need some hints because once you start looking at chemical reactions, all they look like is a bunch of letters and with some arrows between them. So what I want you to do is to look on the product side. The product side is over here. The MgS, the NaCl, there will only be one chemical on the product side. And you're going to say, well, Sturman, there's a 2 here. That's 2 sodium chlorides. Isn't that 2 chemicals? And no, it's two molecules, but they are the same chemical, right? Same thing down here with ammonia. I only make ammonia. It's not important that I make 2 or 3 or 4 of them. It's just that I have one chemical. There's no plus sign on the product side, on the right side. Okay, so over here, like my reaction above, we have one couple. I started off with 2 separate people and I wind up with one couple. Down here, I start off with 2 separate elements. I wind up with one chemical. Okay, so take a look at this. I start off with a couple. I wind up with 2 separate people. How would you describe that? Do you have any words for that? Like does English, in English, how do we tell people what's going on there? That you start off with a couple and you wind up with single people. Well, I can tell you what a chemist would call it. A chemist is going to call this a decomposition reaction. So the time that you most often hear the word decomposition is when we're talking about dead things, right? So it works there too. What's going to happen is that you start off with one body, right? So you have a living being and it dies and it decomposes. It falls apart into lots of individual pieces. So just like I had a couple up here, they were together and then they fall apart into separate pieces. So chemically, this is going to look like this. You saw this reaction before backwards. I'm going to start off with ammonia and I'm going to decompose it into its individual elements, into the nitrogen and the hydrogen. Or here, I could take water. We could split the water into oxygen and hydrogen. So again, we're going to need a hint. Like, how do we look at some chemical reactions and know that this is a decomposition? And what you should be looking for is on the reactant side. So on the left side, you will see one chemical, right? Up here, you see one couple. One couple falls apart into multiple things. And fun fact, decomposition and synthesis are really the same thing. They're just in opposite directions. Synthesis is decomposition backwards. Okay. Okay. What about this situation? Looks like I've got a couple up here and a single guy. And then after some time, whoa, I've got a couple, but it's not the same couple. And I've got a single guy, but it's not the same single guy. So how would you describe this if it happened to one of your friends? Like if you had a friend who was in a relationship and then along came a single person and then, ooh. Well, chemists have a name for this. They call it a single replacement. So up here, we have this guy in the dark colored clothes. He's going to replace the guy in the light colored clothes. That there is one replacement, single replacement. Some people will call this a single displacement. It's fine with me. I don't mind the terminology difference. All I'm really looking for is the word single so that I know you know that it's either a single replacement or a displacement. So chemically, it'll look like this. We've got silver bonded to a nitrate. So silver is dating the nitrate, and we've got a copper that's all by itself. And the copper is going to come over here and it's going to bump out the silver. So the copper is now going to date the nitrate, and the silver is going to be left by itself. Another example would be this one, where potassium comes over and it bumps out the hydrogen, and the potassium is now going to date an oxygen and a hydrogen, and the hydrogen will be left by itself. So we're going to need another hint. So when you're looking for hints, when you're trying to figure out like what kind of a reaction is this, you want to look for an element. So in the first reaction, we've got an element, Cu. It's got a capital letter all by itself, right? Capital, lowercase. Where over here, AgNO, there are three capital letters. That tells you that's a compound. But this guy, one capital letter, one capital letter. So they are elements, and this is a compound. In order to be single replacement, you have to have an element on both sides. So in the second example, you've got the K and the H. There are elements. All right. What if you had two couples, couple plus another couple, and then you put them together and you still wind up with two couples, but those couples are now mixed together? Like, do we have a description of that in English? Like, what would TikTok say on that one? So come up with a description, put it in there. I'll tell you what a chemist would call it. A chemist is going to call it a double replacement because there are two people who are replacing. So we start off with two couples, and it's like in math class where you're foiling things. Like the inside people, this guy with the light clothes and the girl with the dark clothes, they start to date. And the outside people, the man with the dark clothes and the woman with the light clothes, they start to date. So we call that a double replacement or a double displacement. Either one's fine. Chemically, it's going to look like this. I've got silver dating or bonded to a nitrate, and I've got a hydrogen bonded to a chlorine. And then they're going to decide, you know what? I think I like the other one better. So hydrogen will come over here and date a nitrate, and the silver will start to date the chlorine. So the outside chemicals, the silver and the chlorine, are going to date, and the inside chemicals, the H and the NO3, will start to date. Or another example, I've got iron 2 sulfate and sodium carbonate, The sodium is going to come over and bond with the sulfate, so I'll get sodium sulfate. And the iron will go over here and date the carbonate. If you want a hint, the easiest way to spot them is that they're super long. You have to have two compounds on both sides to be double replacement. And so that usually takes a bunch of letters. So if you see them in a list, you'll see like some reactions are short when you write them out and some of them are long. If it's really long, it's going to be double replacement. Okay, got another weird one. At first glance, this is going to look like a double replacement. I've got a couple up here, a boy and a girl, but over here, I've got twins. So do we have any way to describe twins and a couple, and then the two twins wind up dating the other couple? Let's see if you can come up with something. Chemists do have a name for this, because these twins are going to represent an oxygen molecule. So this is an O and this is an O. So this is an O2 molecule right here. And when this happens right here, we're going to call this an oxidation reaction. Literally, we're going to add oxygen to everything. Or you might have heard of it called combustion, because when you add oxygen to things, you're burning them. Right? Combustion is to burn them. You need oxygen to combust. So some chemical examples might look like this. If I take iron and I jam oxygen onto it, I make rust. That's an example of an oxidation or a combustion reaction. I could take methane, like the gas that comes out of the jet on my desk, and add oxygen to it, and I can make carbon dioxide and water. So we need a hint, as always. This one's pretty easy to spot. You are going to have oxygen as one of your reactants. So in order to be an oxidation, you must have O2 on the left side of your reaction, on the reactant side. Okay, so I gave you 5 types of reactions: synthesis, decomposition, single replacement, double replacement, and oxidation. So is every reaction one of these 5 types? Nope. No. It's never that simple. In fact, if you take AP Chem at some point in your future, you'll actually find out that AP Chem uses a different set of possible reactions. Chemistry is complicated. But this is one way to break them down, which helps people to stick them into categories. Some synthesis reactions can be both a synthesis and an oxidation. So for example, if I stick potassium and oxygen together, I get potassium oxide. That's an oxidation because I'm adding oxygen, but it's also a synthesis because I get one product. Some reactions can be complex. They might be a combination of 2 types of reactions, such as like I put some chemicals together and first they do a single replacement, but then the couple that's formed. So in a single replacement, you form a couple, you form a compound. That compound might be unstable and it might decompose. On the test, I'm only going to give you reactions that fit one of the 5 types that I showed you in this presentation. So last year in biology, you learned about photosynthesis, and there's a synthesis in the name. It is photosynthesis. Is it a synthesis reaction? So photosynthesis, we call it photosynthesis because there's light helping to make the sugar, synthesize the sugar. Would a chemist describe this thing as a synthesis reaction? Kind of. But let's walk through the things that you're supposed to know and see why it's complex. There are 2 products, right? We make glucose, C6H12O6, and we make oxygen in photosynthesis. That's 2 products. And earlier in this presentation, I told you that the way that you see a synthesis is that you make one product. So it doesn't seem to quite fit a synthesis reaction if we look at the products. There are two reactants, so that rules out a decomposition because I told you earlier decompositions always start with one reactant. Oxygen is the only element, so there is an oxygen. Can it be an oxidation or a combustion? And the answer is no. It can't be oxidation because the oxygen is coming out. It's not a reactant on the left side. And this can't be a single replacement either because we only have one element. It's the oxygen. And a single replacement, you need to have elements on both sides. Oxygen's not a reactant, so it's not an oxidation or a combustion. It can't be double replacement either. You could say, well, look, we have carbon dating oxygen and we have hydrogen dating oxygen. Well, yeah, but according to what I told you earlier, the H and the O should start to date and give me water, and the O and the C should start to date and give me carbon dioxide. And that doesn't happen. So this is not a double replacement either. If I had to guess, I would tell you that synthesis is probably a combination, photosynthesis is probably a combination of synthesis and decomposition reactions. If you wind up taking AP biology at some point, you'll find out that photosynthesis, it's a lot. Like this reaction that you learned last year in biology, it's a very simplified version of what's really going on inside a plant. Okay, take these notes, submit them, and then you're going to use what you learned here to identify some reactions that are in your other assignment.